Hi, I'm Robert Hilbert. This is my write-up for regression analysis early exam number 1. So anyways, let's get started. Let's start with exercise 1. What did I learn and what are my main takeaways? So starting off, we have an MLR model and we run our significance tests, we test our assumptions, and we continue to check those assumptions and see how multicollinearity plays into this. So immediately right off the bat, multicollinearity needs to be under control because if you don't take care of it, there's a very big chance that it could end up like wrecking your model. You can't use a singular matrix. That's just not good science. And there also what could be at play are redundant variables. Variables that aren't significant, yet the model itself is significant. Like you can very clearly see there's a sizable difference between regular R squared and adjusted R squared. That's the kind of difference that redundant variables pose. And so you want to figure out can you get rid of these while still keeping the sanctity of the model intact? And that brings us to model building. You want to, and how can you do it efficiently? AIC, BIC, you decide which variables you can keep and which ones you can toss. And in doing so, you can you can build a model that doesn't mean going through 2 to the power of p different models and finding which is the best. That would take way more computation than is necessary or reasonable. And that brings us to exercise 2, polynomial. And first, actually, we start off with SLR, but it's polynomial because we realize this isn't this model just does not fit in SLR. Goodness of fit is very important, and that's that makes the real difference, and that's why residual analysis is important. You wouldn't you wouldn't know that these are actually parabolic if you didn't at least look at the residuals, and you would know that the assumptions of SLR are immediately broken. You can't use it, and this also is a clear indicator that SLR has sizable limitations, and polynomial regression also is subject to some limitations of its own. And this is exactly why you need to be incredibly careful with what you're doing, and you need to use your actual best judgment. You can't go on autopilot when doing regression. Exercise 3, the theoretical derivations. This is a lot of ma- matrix algebra, linear algebra, proofs, and immediately you learn that matrices and their identities are very important. Being able to manipulate them is key in order to being able to solve problems that you wouldn't think solvable. For example, if we scroll down, show that residuals are orthogonal to y hat. You wouldn't, from the surface of it, y hat and e look like very different matrices. How can they be zero? So immediately you go from to y minus y hat, and then you realize, oh wait, this is x beta, it's et cetera, et cetera, and oh, this is just the hat matrix. But then the hat matrix is symmetric, so it's equal to the transpose. But then if you just multiply it by itself, it's idempotent, and then it's just the hat matrix again. And then you can finally get in a form where you can prove to yourself, yes, it is actually zero. This is very powerful, and being able to leverage this into any other sort of situation is very good for statistics, and it'll allow you to make much more powerful assumptions. And this is exactly what this test was for. I am very grateful for having taken it, and I feel like I learned a lot. Thank you so much. Have a good day. Bye.